give a warm welcome to Alexis, qui est sur son téléphone. So please give a warm welcome to Alexis, who will be giving the next keynote.
Thank you. Thank you, Jan. So this is my first time in ConFoo, and I'm very impressed, Jan. You do a great job, and it's a very nice conference. And also, I'm just very happy to be there with you to discuss, to present you these keynotes, and I hope it will be kind of inspirant. Sorry, sometimes I have trouble speaking English. So I guess you guys are able to decode French and English, but I try to keep the English. So what makes a great software engineer? You probably have an idea about that, and if you are here, it's maybe that you might be a great software engineer yourself, and you will see why at the end of the presentation, of course, so this is to keep you awake till the end. But most of the time when we ask a CEO or a manager what he thinks about software engineering and how we see the good software engineering, the best software engineering, the first thing that pops into the mind is the productivity. So most of the time, if you ask somebody, he will tell you, oh, a good software engineer is someone that is able to produce these things in 2 days to 3 days. And bad software engineering might take 10 days, whatever. So, and this is not a new concept, because in the 60s, studies have been conducted, and they realized that between the best and the worst software engineer, there was a ratio of 28x between the best and the worst, mostly based on line of code produced by the software engineer. And at the time, it makes sense, because we had software, we did not have tools. Programming was something really, really painful. We had people most of the time used to write code on the paper and pass it to somebody who will transcript the code into the machine, and it goes to the compiler and goes to the mainframe and comes back, etc. And somebody who were able to code at first time a good program was really efficient, and the productivity was impressive. But nowadays, 50 years later, is it still the case? Unless you have been living in a cave those 3 months, you probably heard about ChatGPT or GPT-3. And you probably have seen some example of code generated by machine. And myself, I used ChatGPT, and I asked ChatGPT, are you a great software engineer? We might be curious about that. So the answer is nice. It's kind of, I would say, not frightening one. It's kind. I would say it looks like somebody just wrote the answer. It's not like a machine would produce that, and that kind of makes sense, because if you see how it works, how OpenAI did ChatGPT, this is from the website of OpenAI. They used human supervisors to train the machine, and based on prompt, based on the question you ask. The humans were in charge of producing the response, and they train a model based on that. And after, with this human supervising the stuff, they again take the data set of prompt, and they ask the ChatGPT to produce result, and they ask again human to sort from the best to the worst the result, and it produced what they call a model for reward. And then, based on this reward model, they train the GPT to produce answer that could match the question. And if you're not very aware of how GPT works, it is based on, it's kind of simple. It crawls the whole internet, it crawls the whole data we have around, and it constructs a model that is able to generate sentences. And it could generate code, it could generate text, it could generate stuff, whatever. And it is really impressive now, because we saw that it is able to generate poems, it is able to generate anything. And yeah, this is very impressive. And also, maybe you saw what Codex is. This is kind of a variation of ChatGPT, where you have a prompt here, and you type something on the prompt, and is it going to start? Okay, let me see. Okay, too bad. So you type something on the prompt, and it generates code. And you keep typing stuff like, I want the asteroid to move 2 times faster than the ship. You type, I want this to move like that. I want to, and it generates code, lines of code, flow of codes like that. So you would say you could just develop without having any knowledge of programming languages, just by typing stuff and describing what you want. And this is possible. Obviously, this is kind of classical example you get, and we know that this is not real application, because developing a game application like that is always what you see in demo, but in real life, this is not exactly what you get. So is it reliable, by the way? Because you just ask ChatGPT to produce something, but does it produce something reliable? And we know that if we produce code, we don't want to have flaws in our code, because if you are dealing with software in finance, if you have code generated by machine that are generating bugs, it could be really problematic. So here we can see that you ask for a simple question, like 3 to the power of 73, and the answer might look really good, but in fact it's completely wrong. And you realize that ChatGPT is not able to conceptualize the formula behind 3 to the power of 73. It is just generating content based on example you can see it has seen on the internet, and the result produced is completely wrong. So it hallucinates, like we said, stuff, but it's not real. It's not a real concept that is behind. So for really hard science stuff, it's kind of very risky to use this kind of technology to produce accurate content. One other example is, I hope it will start. No? Okay, too bad, I'm going to explain this. So they use ChatGPT against Stockfish, which is an algorithm for chess. And ChatGPT is going, here in this example, plays moves based on example. And the first move of the game are okay, because it's opening game. Generally, you have example on the internet, and it works. And Stockfish does not make mistakes. But when you arrive at the middle game or the end game, it is completely wrong. It moves a piece of the chess completely randomly. So you realize that it has not been able to understand the rules of the chess. And it is just producing content just like that, kind of randomly at one point. So, okay, nice. We have this, and we could say, no worries for software development. Machine learning is just producing stuff, but there is no reason to be concerned. Okay, journalists or people writing content could be concerned about that, but for us, okay, ChatGPT, whatever, no problem, we are not concerned. Are we? So first, 5 years ago, GPT-2 was kind of funny thing. You just used it, and it was not that performing well. And now we realize that with ChatGPT-3 and GPT-3, we can see some interesting stuff, but GPT-4 is coming soon. And as you can see, compared to GPT-3, the data set used for the training is much bigger. So you might expect something more accurate, still random or still statistically based, but still, again, more accurate. So your content generated by GPT will be better and better. And who knows in 10 years where we will be. And okay, GPT is based on language model, based on what you see on internet. But what if you apply another layer on that? And this is what guys from AlphaCode did. They took GitHub source, they took contest problems and solution. Based on that, they trained a machine that was able to generate solution. They generate 1 million solution. They generate test case based on the description. They filter the solution and produce clusters of solution, and then submit the solution to the contest. And here you have an example. On the left, you have the description, you have the test, and on the right, you have the code. The code is not that bad. You can see that, okay, there are some good stuff here. The funny thing, and you might think about that, is that the description is much, much, much longer than the code. And some would say, why having this? I could write the code directly and not write the description. And this is losing time. Maybe. Or on the other hand, maybe describing stuff very precisely could be a way of programming somehow. And in fact, AlphaCode is performing quite well, much better than the average. It was very impressive for the result. And I'm sure myself I will be as good as AlphaCode in some problems, just like that. I'm a little bit rusty in programming, by the way, so that could explain. But you say, okay, AlphaCode is nice, and And still, we saw that it generates kind of simple code. But can we have machine learning stuff generating complex code with function? Of course. Now we have some guys from Stanford University that have developed Parcel. And this thing is able to generate, to decompose a problem with function, with description of the function, with reference of a function between each others, with constraint on the function. And it structured the code by having this composition of function decoupled somehow. And that where the machine is able to generate code for each function, to improve each function. So yes, this is happening right now. And they have been able to generate software, a Lisp interpreter using 21 functions that is working just based on the description. So, okay, this is just the beginning. In 10 years, where will we be? But, okay, code generation is nice. You would say, oh, no problem, algorithm. Algorithm is still something we can do. Well, again, yes, machine can generate algorithm, and even better algorithm than the best human. Here, the guys from AlphaCode, from DeepMind, so the same guys working on AlphaCode, applied the same concept on matrix multiplication problem. And just like you have a Go table with dots, with kind of matrix, here they applied the same rules, but for the same principle. But the rules was try to solve a problem with the right solution in the minimum moves. And for most of the case, it found the best algorithm, even better than the best human algorithm known for now. But you can see on the right that the algorithm is a kind of brute force, not very elegant, but still better. So yes, that's quite impressive. But should we worry? Because, okay, these things are tools for me. I mean, okay, this is cool. It generates algorithm. It helps me to solve problems. And this is not new because in the 90s and even the beginning of 2000, there were this kind of move where people were saying the software developer, as we know, is going to change forever because now we have tools where you can use an interface to describe what you want. You can just click and produce an application, and that will be all. And there are tons of applications right now using this kind of what we call rapid application development tools. So this is not new. Tools have been around for decades, and it's improving always. It's always improving, and we are still here. So does it mean that we are going to disappear? I'm not sure. So like somebody said on Twitter, it's not like machine learning is going to replace you, but maybe a person using machine learning is going to replace you. So this is more general concept. It's not necessarily for software development. But you might consider this. But is it only productivity that matters? Because, okay, nowadays, the difference between the best and the worst is maybe not 28, like we had in the 60s. Maybe it's shorter because it's smaller, because we have tools that helps anybody to develop. And we can see that because I have friends, they are not software developers. They did a training, and in 6 months, they've been able to produce really efficient code that is going on production. And they are using tools, and they are assisted by software like linter and whatever, and compilers and IDE, and they are productive somehow. So, what makes a great software engineer? People from Washington University conduct studies, and they interview expert software engineer, and they ask them, what do you think about what makes a great software engineer? And the funny thing is that they gather this in this figure. Productivity is just one little side, one little stuff in all the stuff that are required to be a great software engineer, considering these interviews. And there are two sides. They are what they call internal, so anything related to you. And here we can see that it's not only productivity, it's being passionate, being constantly improving yourself, being curious, so this is maybe why you are here, but also being able to do key decision, being to make the right choice. And on the other side, on the teammate side, it's not only ourselves alone that are developing software. Now it's more, I don't think there is lots of projects with a solo developer working on it, and even if it's a solo developing stuff like Linus Torvald did with Linux, at one point, he published the code and people joined him. So when you produce code, you never know if it's going to be for you alone. So at one point, you will need to share stuff. You will need to discuss with others. And being able to share, to exchange, to mentor is something that is really valuable as a real software engineer. And on the other side, the code you produce should also be, you have to be aware that it's not for yourself alone. It's going to be reused by somebody else. And based on that, you have to be able to deliver elegant, creative code. So productivity is not the only criterion. It's more about how engineering is conducted, how you interact with management, with your subordinates, your partner. So it's not only a technical thing, it's how they said, social-technical undertaking. We are not alone, we are not coding for ourselves, we are coding with each other, we are doing pull requests, it is reviewed. So everybody learned to, when you come to a new team, you learn how the team works, and there are reviews, and you try to discuss with each other, you have standards in the teams, and it's just only you. Also, delivering code is not only the thing. The code has to be creative, to be long-term, because you know that at one point, if you go very fast, you can deliver one thing in one day, but is it really going to be reliable in the future? Is it future-proof? It's easy to produce very fast code, but it could be big rubbish code, because at one day you will have to refactor, and at that point it will cost you a lot. So yeah, it's not just delivering, it's delivering the right code. And being able to do critical decisions, like I said, because at one point also you will have to choose the right path. You will have to choose if you need to choose to tackle complex problem and, for example, see the best architecture and take the decision, because if you take the wrong path, it's going to be very difficult to correct the stuff months after. And above all the thing, learning. Because we are in a world where everything is changing every day. And 10 years ago, the way we developed software was completely different than today. And there are constantly new stuff, new framework, new database, I don't know. Every decade has its own stuff. Last decade was more about new programming language, new databases. Now it's maybe more the machine learning decade. So things are constantly changing, and you need to be able to learn to constantly improve your skills, all your skills. So I asked ChatGPT what makes a great software engineer, and I could have put this slide at the beginning of the presentation, and the presentation would have taken 5 minutes, and that's it. Because you can see that the answer is quite good. It just said, it's a resume of what I said, so it's very impressive. Probably somebody already wrote these things on the internet, and ChatGPT just transcribed this in his way. And if you ask me what really makes a great software engineer, I would say we have to be courageous. We have to have strong willpower, because when it comes to software development, the beginning of the path of the track are generally quite easy. But at one point, things begin to become really hard. And it's like climbing a mountain, to take the analogy with Jan and the valley and the mountain. You have to climb the mountain, and you have to be brave, you have to be courageous. And one way to tackle this is with discipline. If you have a strong discipline, if you every day you don't take the easy way, you don't take the lazy way, you will be able to achieve wonderful things. So I'm telling you, be brave, be courageous, and you will be able to be a great software engineer. Thank you very much.